Hi everyone, this is the QP Learning channel which will give you the information about Neet and JEE Mains and question and answer and exam pattern and exam question papers and everything. So before watching this video, please press the subscribe button along with the bell icon. If you press the bell icon, definitely you will get the new notification whenever I upload the new videos into the YouTube. The first question, in the Geiger-Marsden experiment, find the distance of the closest approach of the nucleus of a 7.7 mega electron volts of energy of alpha particle before it comes momentarily to rest and reverses its direction. So Z for the gold nucleus, which is equal to 79. 79 is the atomic number of the gold. So options given, so 10 Fm, F means it is a Fermi meter, and here 20 Fm, 30 and 40. So how we have to solve such kind of the problems? See, here the closest approach of the nucleus, when the alpha particles, here the first we have to understand the concept. See, you take, this is one of the gold nucleus. So this is the gold atom or the gold nucleus, this is okay. So here just alpha particles are coming towards the nucleus. Clear? This is the alpha particles. This is the gold nucleus. So when the particles, the kinetic energy of the particle is 7.7 mega electron volt. These particles are moving towards the nucleus of the gold atom. So alpha particle is positive charge, even nucleus is also has positive charge. Positive repulsion will be takes place. So when the alpha particles are moving closer to the nucleus, immediately the positive and positive repulsion will be takes place. Due to repulsion, this alpha particle won't touch to the nucleus. Immediately its kinetic energy 0 at the certain point, and after that immediately the alpha particle is retracing back. So here the kinetic energy will be decreases, means completely 0, and when the particle is moving back direction, its potential energy is increases. So here one concept we have to understand clearly. So initial, okay, the kinetic energy of the alpha particle should be equal to the potential energy of the system. So kinetic energy they given, the kinetic energy I will take it as the K is equal to the potential energy of the two charges. You know very well, you learned in the first chapter electrostatic, that is the potential energy is equal to 1 by 4 pi epsilon naught into, so here 2 q's, here this is the charge of the alpha particle is 2e into the charge of nucleus is ZE divided by it is the distance. So this is the potential energy of the system. Next, so our target is to find the distance of closest approach, that is required. So here K is given, this is constant, just I will simplify little bit formula. The K is equal to, so 1 by the 4 pi epsilon naught into E square, so 2E square Z divided by D. Okay, next, So here substitute the values. For example, just you interchange. Actually our requirement is D and K given. We have to find the D, so that D is equal to, so 1 by the 4 pi epsilon naught into 2 E square Z divided by K. K means here kinetic energy. So this is constant. 1 by 4 pi epsilon naught is constant. So that is 9 into 10 to the power of 9 into 2. Here E means it is a charge of electron. So that is 1.6 into 10 to the power of minus 19 whole square. Z is the atomic number of the gold is 79 whole divided by K. K means 7.7 into here mega electron volt. Mega means it is 10 to the power of 6. Electron volt means that is we are going to convert 1.6 into 10 to the power of minus 19. You simplify all about equation. So here 9 into 8, 18, 9 to the 18 into here 79 is there, 79, okay, into 16 square. 16 square means it is 2.56 into 10 to the power of 19 to the minus 38 whole divided by, so this 7.7 into 1.6 into here minus 19 plus 6, it is 10 to the power of minus 13. The finally you simplify all this, finally you are going to get it is nearly, so 29.85 into 10 to the power of minus 15. So 1 Fermi is equal to 10 to the power of minus 15. So finally in round figure it is the 30 Fm. So it is the right answer is this one. The option C is the right answer. In second question, in an atom the ratio of radius of orbit of electron to the radius of the nucleus. So that ratio we have to identify. So as you know that by doing alpha scattering experiment, the radius of the electron, orbit of the electron is nearly 10 to the power of minus 10 meter is there. Same thing you go for the radius of the nucleus is, 10 to the power of minus 15 meter. Just they are going to ask in an atom the ratio of the radius, the ratio of these two things. The first one is the radius of the orbit is 10 to the power of minus 10 divided by 10 to the power of minus 15. Just you bring the minus 15, 10 to the power of minus 15, you bring it up. So here 10 to the power of minus 10 into 10 to the power of plus 15. It will become plus 15. When bases are same, powers we can add. So 10 to the power of plus, because the bigger number is as plus, so that 10 to the power of 5 is the answer. So here option B. The third question is that the relation between the orbit, so carefully you listen, your orbit radius and the electron velocity for a dynamically stable orbit in a hydrogen atom is. So here the 4 option is given, just we have to work out for it. So radius, orbit radius and electron velocity. So you know that, so if you consider an atom, so inside the atom, so there is a nucleus, around the nucleus electrons are revolving. Okay, so just here we have to identify the relation. So here one thing you observe, the electrons are revolving around the nucleus, that is due to centrifugal force, and the nucleus is positive charge, electron is negative charge, and positive and negative there is a force of attraction between the nucleus and the electron. This is also one force, that name is called as electrostatic force. The electrostatic force should be equal to centrifugal force, then only it is possible of these electrons are revolving. Are you clear? So that I will take, what is that? The one force, what is that? That is the centrifugal force should be equal to the electrostatic force. E means electrostatic force. Then only the electron will be in revolving around the nucleus. So centrifugal force, you know that mv square divided by r is equal to Fe, electrostatic force. So that is 1 by 4 phi epsilon naught into the Q1 and Q2. Here I will take the electron charge. This is also one charge, E square, E into E square, 2 charges. So divided by the R square. So here 1 R and this square is get cancelled. Okay. So here M is there. Actually we want V outside. So M you send it this side. So what is left? So V square is equal to E square whole divided by 4 phi epsilon naught into, here M will come here. So M into R. Just you remove the square for that. So V is equal to, you put a root, so like that, root E square, so divided by the 4 phi epsilon naught mr. So this is the relation between the velocity and the orbit radius. So where is that? Just you find here, E square divided by E, so root of E square divided by 4 phi epsilon naught into mr. So this is the right option. The fourth question is that the relation between the kinetic energy K and the potential energy U of an electron moving in an orbit around the nucleus is. So here 4 option, U is equal to minus K, U is equal to minus 2K, and U is equal to minus 3K, and one more, U is equal to minus 1 by 2K. So how to solve this problem? So kinetic energy, means that is Ke, they given K, so instead of that you take directly you take the K means it is the kinetic energy is equal to of mv square, and the potential energy U is equal to, already you know that just before we discussed this kinetic energy, 1 by 4 phi epsilon naught into E square divided by R. This is the potential energy. Just we have to compare the relation. So here mv square is there, here K is there, okay, K is equal to of, I will write as it is, and mv square, before the derivation we learned the centrifugal force should be equal to the electrostatic force. Here mv square divided by R is equal to 1 by 4 phi epsilon naught into E square divided by R square, that is, this is epsilon naught. So here this R and this square is cancelled. See here mv square is equal to 1 by 4 phi epsilon naught E square divided by R is. So in the place of here mv square, I will substitute this one. Okay. So here the 1 by the 4 phi epsilon naught into E square divided by R. Okay. So potential energy is that 1 by 4 phi epsilon naught E square by R, this and this is similar is there. In this place completely I will put potential energy, it is in negative, so that K is equal to, so 1 by 2, here minus negative means I will take the here negative into U, this is the, we are placing U. or else you multiply here minus, so this will become minus and this will become plus. So where this is the formula, there you substitute minus u. Minus u means minus will come here, u is here. So here finally the u is equal to minus of 2k. So u is equal to minus 2k is the final answer. That is the option B. The fifth question is that the volume occupied by an atom is the greater than the volume of the nucleus by the factor is about. Okay, that we have to calculate. Here options 10 to the power of 1, 10 to the power of 5 and 10 to the power of 10 and 10 to the power of 15 is there. So volume occupied by an atom, just one thing you remember, so what is the structure of atom? So that is also sphere, and inside the atom, so nucleus is also sphere, so that both are sphere. So here the volume of the sphere, as you know that, so volume of the sphere, the formula is that the 4 by 3 pi r cube. This is the volume of sphere. Just now I am going to take the two volumes. So what is that? That is the ratio of the volume of atom, first one, to the volume occupied. So same, the volume of nucleus, which is equal to the volume is 4 by 3, so pi r cube. It is the r means it is the radius of the atom from ear to ear, whole divided by the volume of the nucleus. So that is also 4 by 3 the pi 4 by 3 pi r cube. So here the capital R is the radius of the nucleus. So this is the radius of the nucleus. So here pi 4 by 3 and here is also pi 4 by 3 is cancelled. Here r means radius. See, already we know that approximate radius of the atom is minus 10 to the power of minus 10. It is the whole cube, whole divided by the radius of the nucleus is also, we know that, that is the standard 10 to the power of minus 15 whole cube. So finally, so 10 3s are 30. So 10 to the power of minus 30 divided by 15 3s are 45, 10 to the power of minus 45. So here the finally we will get the, when 10 to the power of minus 45 is goes upside, so it will become plus, so that finally the 10 to the power of, so 45 minus 30, it is a plus 50 is the answer. So here option D is the right answer.